Good evening, everyone, and thank you all for joining us today. My name is Rashmita, and I am the event planner for Microsoft Reactor India. This session will run over the next 60 minutes, including Q&A. But before we begin, please take a moment to read our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat section will be open throughout, and we do encourage you all to participate. So please feel free to drop all your questions in the chat section. I would now like to welcome Abhishek, our speaker for today's session. Abhishek is working as a senior security architect with the GitHub Expert Service team. He has overall 15 plus years of industry experience working as a developer and security practitioner. But for now, I will hand over to Abhishek to begin the session. Let me bring him into the stream. There you go.
Hey,
And
hey, Rashmita. Hi,
hey,
everyone.
Abhishek.
Good evening, good afternoon, good morning, from wherever you're connected to. Uh, I hope my screen and audio is visible. Rashmita, just a quick check.
Yes, yes,
Yes, okay.
both are good. Yeah.
Okay, so hello, everyone. So I think, as we all know, so we are here to discuss about developer for security with GitHub Advanced Security. Just a few housekeeping notes before we get started. We can post questions, as Rashmita mentioned, in the chat in the YouTube stream, or like, and we'll take the questions in the end. Also, I have my colleagues Dhruv and Arun who will be assisting with some Q&A as we move forward, right? So let's get started. So myself, Abhishek, I've been working with GitHub and especially focusing on the advanced security, GitHub Advanced Security portfolio, um, helping customers to roll out advanced security with primary focus on, as I said, like removing the friction between the tooling implementation with developers. Right, many a times we have seen developers with introduction of new tools, there is a friction, and they, with already burdened workload, they kind of push back on new tooling. Right, so with GitHub, the whole premises and that's what we'll see today. How we can integrate advanced security or application security as such, right? Natively integrated with the developer workflows. So today's agenda, let's go through. So we'll have a brief introduction about the GitHub Advanced Security tooling, the ecosystem, what all products we offer as part of GitHub Advanced Security. Uh, then delve deep into the different verticals like the secret scanning, the code scanning with CodeQL, the supply chain security with DePenda, and the security overview. Basically, how do you see and manage your risk and get a risk visibility across your portfolio, right, of applications and projects. So as an introduction, the whole philosophy behind GitHub Advanced Security was really to have it built into the developer lifecycle. It is a tool set made with a developer first mindset, and we really wanted to integrate it into their ecosystem. So, just to give another perspective, like, I'm not going to spend too much time today on slides. Few slides and more hands-on to show you the actual tooling and what are the different controls and how you can roll out some of these tool sets into the developer ecosystem, right? So with GitHub primarily and all the integration touch points. So with advanced security, we can integrate into each of the stage of the SDLC, and we'll show you how we can do that. Be it when developers write code in their IDEs, how vulnerabilities can be pulled up into the IDE. When developers push code into the repository, into GitHub repository, how vulnerability scans can be integrated into the pull requests, right? Because pull requests is something that developers work on a day in, day out basis. How security architects can review those vulnerabilities when within the PR context and take more informed decision. We'll also look into how secret scanning, because credential leakage is a big problem in the industry, and how we'll see how GitHub solves that issue by proactively stopping commits by looking if there are accidental credentials in the source code, right? And developers are trying to push that code. There are ways of blocking your commits. We'll also see how you can, in case we have a GitHub partner program, wherein partners like Amazon, AWS, Azure, right? Everyone has collaborated with GitHub to identify their credentials, like their keys and user tokens, right? In any case, if those kind of keys and tokens are pushed into the repository, there are ways of validating, like not just visibility of the of the token, but also validation of the vulnerable of the token, right? If are those tokens active, are they inactive, right? And then take more informed decision and help you in prioritization. So then we also have the supply chain security. We'll see how Dependa comes into play here to give you a visibility of your supply chain, as from the software bill of materials. Also see how it can give you a risk visibility of your complete third-party usage, right? Like what kind of vulnerabilities reside on your direct dependencies, your transient dependencies, how again you can prioritize your vulnerability, open source vulnerability, right? So obviously, with third party dependencies, right, there can be a lot of uh, vulnerabilities which can be thrown once the scan is done. But again, how do you reduce the vulnerability fatigue, right, with developers, and prioritize which vulnerabilities can be fixed with certain kind of rule implementation within the GitHub tooling. We'll then talk about code scanning with CodeQL. So that's the static application security testing tool from GitHub. Different ways of rolling out and different strategies of rolling out CodeQL within GitHub. Scanning with PRs, default scanning without need of knowing actions in the background, right? Or if you want more complicated build strategies, you can use GitHub Actions. How to use GitHub Actions to roll out CodeQL. So these are different touch points of rollout of GitHub Advanced Security offerings at different stages of your SDLC. And we also see like how you can probably bring in, if you have already have a third-party scanner, right, an application security tool, be a container scanning tool or an infrastructure as code secure scanning tool. As long how we'll see, as long as it outputs a SARI format, which is a standard industry format for vulnerability results reporting, as long as the tool outputs the vulnerability data in a SARI format, we can see how those data can be input into GitHub security dashboard, right? So that you have one dashboard with all your vulnerabilities in a single place. So with having said that, so let's see what are the offerings. As I said, we have dependency graph to view your dependencies, advisory database, basically the GitHub advisory database. It's a canonical database of dependencies and vulnerabilities, right? Security alerts and updates, notifications of vulnerabilities in your dependencies, and pull requests to fix them. So when it comes to your supply chain, we not only give you a visibility of the vulnerability, we also make it simpler for you to faster remediate those vulnerabilities by automatically create pull requests for you. We'll soon see those in action when we do the demo. The dependency review, identify new dependencies and vulnerabilities in the PR. So if, like I said, if there are security vulnerabilities in the third-party components, or if your third-party component is outdated, right? Like you're not using the latest version of the component. So all those use cases can be automated with automated PR generation, so that your developers and architects don't spend too much time in doing manual repetitive tasks, right? PRs are ready. They just come and review, and if the PR, if it's ready to go, they just merge the PR, and your vulnerabilities are fixed, or your open source components are to the latest version, right? So, and then we have secret scanning. What it does, it find API tokens or other secrets exposed whenever in your Git history, not just the present commit that the developers are doing. Once you enable secret scanning, it will go through a complete history of your Git repository and see if there are occurrences of any kind of keys that has been leaked into your repository. Code scanning, the static analysis for every Git push integrated with developer workflow and powered by CodeQL. So CodeQL is the engine that GitHub uses to run your code scanning. Um, then, apart from the core offerings, we also have certain best practices that we recommend to organizations when they're rolling out. It's just security best practices, right? Branch protection is very important. Enforce rules or requirements for push to a branch or merging PRs, right? What kind of rules? Because that's where you will have, once you define the rules, that's where you will enforce this, what kind of constructs you're putting, what kind of checks and constructs you're putting, so that your code that you're coming from a developer from his feature branch, his or her feature branch or release branches, or feature branch into the release or your stable branches. Commit signing is another very important aspect. We highly recommend teams to follow, so that you enforce, so that you know that the source being committed is from a trusted source developer. And also security overview. We'll see how the dashboarding, when it comes to security overview, will show you what kind of risk visibility we give you within GitHub to get the visibility of your application stack in terms of the most number of vulnerabilities, like which repositories are the most vulnerable, getting the number of vulnerabilities, what is the mean time of remediation, how many days are vulnerabilities remaining open in your application. It's a complete risk posture of your application through your security overview. So now let's start with secret scanning. Okay, so what is secret scanning? Is that it finds secret the moment they are pushed into GitHub. Scan your entire Git history, not just the current commit. The entire Git history is scanned for any, and it is checked for whether there are any keys or tokens that is being leaked into the source code. Easily exclude false positive. There are ways how you can easily exclude false positive if there are false positives. Support for custom patterns for secret scanning. Like obviously we do understand there's there's certain cases wherein a very custom kind of a pattern that needs to be identified or scanned for when enabling secret scanning, right? So we do have provisions wherein customers and organizations can define their own custom patterns, their own like regular expressions, which identifies a very specific use case for them, and then enable those. And once you define that and you enable that against a secret scanning tool, um, any string which matches that regular expression will be highlighted for you as a vulnerability. Push protection, again, a very important feature with GitHub ecosystem, which is part of the secret scanning utility to prevent accidental credential leakage. Basically, what it does is with secret scanning, what we saw is it's more like a reactive. We're assuming that the code is already pushed and we give you a vulnerability inside, right? With push protection, we are making it more proactive and stopping the code to get into the repository itself if there are any credentials into the source code, right? So basically, the commit itself will be blocked if we enable push protection, and we'll see that in action when we do the demo. Push protection for custom pattern is also supported, and then some of the latest features that we have recently launched, which have been discussed in GitHub Universe, which is there is an AI engine also built into the GitHub secret scanning utility, the product, which helps you to write those regular expressions with the help of AI engine, right? Instead of you spending hours to write your own secret scanning, your custom patterns, you can just go to the AI engine, ask the AI engine a particular prompt for asking it for say regular expression for a particular type of string pattern, and we'll see this in action how this AI engine assists you to get faster remediation cycle, right? Basically, the more faster you get the custom pattern out and embedded into your secret scanning engine, the faster you identify those vulnerabilities for you, right? So we'll see this in action as well. So secret scanning, there are many partners who have, as I said earlier, right, who have partnered with GitHub to identify their tokens. So this is just a sample list, but there's a whole lot of list of partner program that organizations have tied up with GitHub. Like the major ones are there: AWS, Atlassian, Azure, Dynatrace, Google Cloud. Any keys or tokens from these providers, right? If they are in this inner source code and it has been committed, and if secret scanning is enabled in your repository, we will flag that as a vulnerability and report it under the security dashboard of GitHub. Uh, so this is part of the partner program, right? So outside the partner program, as I said, there can be scenario wherein there is a very custom need to identify a particular pattern in your source code, right? Which is specific to an organization A, right? So that's where custom patterns come in. Custom patterns will help you identify those patterns which are outside this partner program, right? So we are covering the full landscape, not just the partner programs, but outside the partner program also we are covering those areas. Preventing secret leaks on Git push. This is how GitHub will proactively stop your push or commit requests if there are potential secrets in your source code, right? So if you see this example, someone trying to do a Git push for CLI and it gets Git push push protection is enabled, it will block the commit itself, right? So it will not allow the developer to commit the code, and you are basically ensuring that bad code or vulnerable code is not getting into the source, and you are removing the headache of clearing up the complete Git history and all at a later point of time, right? So you're at the very starting itself, you're blocking the commit when getting into the repository. Custom patterns, again, custom patterns can be defined by your for your enterprise, organization, and repository at multiple stages. You can do that. if there are patterns which are impacting your complete enterprise, right? So you can define a custom pattern at the enterprise level in GitHub. You can also define a pattern at the organization level, or if it's a very local scope, right? If that pattern is impacting only the specific repository, then you can define the pattern at the repository level. So these patterns are used specifically using regular expressions and uses the Hyperscan library. So we'll see this in action soon. Okay, so time for demo. So we have spoken about. So what I'll do is I'll cover one section, directly go to GitHub and show you the demo and the use cases around that offering. Like we spoke about secret scanning. Now let's see secret scanning in live in action. Right. So I have a repository called Mona Gallery MS Reactor. So I'll go to the settings. So basically, this is how you enable the advanced security features within a repository. And I said, like, you can do that in a repository scope, or you can also do it as an organization scope. So it really depends on your organization policies and your enterprise policies at which level those policy enforcements are defined, right? So in this case, I'm going to my repository settings and then code security and analysis. So under code security and analysis, this is where all the configurations and the settings are, right? Whether you want to enable the dependency graphs, we talked about the supply chain security, right? So dependency graphs, the Dependa bot alerts. GitHub Advanced Security, you want to enable and disable. I have already enabled this. Code scanning, do you want to set up? Secret scanning, do you want to enable and disable, right? So if you see secret scanning is right now disabled, I'll go ahead and enable secret scanning. Okay. So if you see here, now I've enabled secret scanning, and then immediately if you see, there are 6 security alerts which has come up for me. So if I go into the security dashboard here under the secret scanning, as you see, these are all the API keys, AWS Access ID keys, GoCard, some tokens which were in the source code, and it has already identified the moment we enable the secret scanning, right? So it gives you instant. This is kind of the low hanging fruit. Like you don't have to do any configuration, just binary, just enable the flag, and you start seeing the results and the vulnerabilities popping up into the security dashboard. So this is the simplest form of identifying and your secrets and tokens in your repositories. And as I said, it not just scans for your last commit, it goes through the complete entire history of your commits, right? Like, and it will also look into your issues and comments and for any credentials leakage there as well, not just your source code. Okay. So now next, going back to the analysis. So let's say how do we define customers? So we have already identified some secrets which are part of the partner program. So these are all secrets which has been identified through the partner program, because these organizations have tied up with GitHub to identify their tokens and keys. And that's why out of the box, when we enabled, we still got those alerts, right? So now let's see in my source code. I'll go to the code. Okay. So in my source code, if I go to this storage component and I'll go to my sources and application.properties. So if I see this application.properties, I see that there is a password called min.io password, which carries the value mona underscore value underscore abc 1 to 4. So this is a very custom secret for us. It's a custom password for us, right? It's not part of any provider program which or partner who is tied up with GitHub. But we do need to, as an organization, we need to safeguard our source code and our organization from leaking this kind of potential, because it might have huge ramifications for the organization if it's leaked in the public domain, right? So now, how do we identify these kind of custom patterns, right? So that's where custom patterns and the regular expressions come into play. So what we'll do here is, inside the secret scanning, we'll write a new pattern. Okay. So now if you see here, there's something called generate with AI. So this is a new feature that has been launched as part of our GitHub universe. So this is in very limited public, limited beta. Okay. So organizations who have the GitHub licenses, they are getting access, but you can also get into the queue request for access. Okay. So we can share you the link, how you can request access for these features. But to show you the use case, what you can tell here is, so this is again an AI engine, right? So we need to ask, or we need to prompt it or with a question which gives us the particular regular expression that we're looking at. So what it's saying is, I want a regular expression that I'll say finds the string string underscore value underscore 1 to 4. So this was the string that we are looking to identify from, and we need a regular expression to capture this particular string format, where okay, so let's see, we see 1 to 4, where the value it is preceding Mona underscore value score is of length 6. Okay, so I'll also give some examples here. So let's say value underscore abc 1 to 4, value underscore x yz 6. Yeah, these are some of the test string that I'm giving to the AI engine. Let's see what it generates and gives us. Okay, so if you see, it gives us a particular format of regular expression. It says it matches any word, character, letter, digit, or underscore exactly 3 times, or matches any digit exactly 3 times, right? So you can directly use these patterns. So as I said, this is an AI engine, right? So you can be very specific in your prompting to the tool to give it to give you a very specific regular expression, right? And use it in your custom pattern definitions, right? And once you import into the custom pattern definition, if I say, okay, I'm happy with the result, right? So characters of exact length. So let's see what else it comes up with. Okay, so if I changed prompt a little, very right, and it has given me another format of regular expression. It's, if you see, one underscore value underscore, it can take any characters, any alphabets A to Z, small or capital, and any numeric characters 0 to 9, right? And I've said that because I know this can be of length of 6 characters, right? We can not more or not less, right? So it has scoped it to length 6. So now I said that, okay, I'm happy with this regular expression. I import it into my definition. I'll give it a name, test pattern, test pattern, test pattern. So the strings are also copied. I'll do a save and dry run. Okay. So dry run is queued. So basically, it will do a test run on the repository to see if there are any matches. Okay, I see there's one match. So once you do the dry run once the dry run is completed, you can do a publish pattern. Okay, and you can also okay, so you can also, as I said, you can also enable push protection for custom patterns. But since I've not enabled push protection as a global configuration for the secret scanning, so it's not allowing me to do that. But I can very well go here in my global settings. I can enable push protection. Okay, and then now if I come back to my custom pattern definition, it should give me the option to enable push protection. Okay. Okay. So now if I go to the security, so earlier we had 6 vulnerabilities reported under secret scanning. Now we have 7. So now the 7th one is the key which has been reported from my application.properties, for which I have written a custom pattern using my AI engine, right? So this is about secret scanning. Like we saw how to enable secret scanning, the default scans, getting instant vulnerability reported for your partner patterns which are outside the partner program. If you want to identify those kind of secrets for your strings, there's a custom pattern that you can write with the help of the AI engine. You can get regular expressions. Okay. And then we also have push protection. So how does so since we have enabled push protection now, so now let's say I will go to the code. You can do it from the ID. It will block that. But for today's demo, what I'm doing is I'll just go to the text password.txt. I'll try to do another. Let's say password equals to Mona underscore value XYZ 123. Let's see if okay, there's underscore here as well. You see if I browse to commit, I'm committing to the branch. Okay, so if you see here, the push protection kicked in. It says secret scanning found a custom pattern named test pattern defined by your admins. Okay, on line 5. So this string already matched the custom pattern, and since push protection is enabled, it's blocking the developer to commit the code itself. So we are taking security right to the developers and proactively stopping commits to get in or bad code to get in the repository itself, right? But there are ways developers can bypass it, and they can capture those events as well, because we don't want to be very obstructive in the developer workflow, right? So what you can say is we do allow users to flag it, saying if it's allowed in used in tests, if it's a false positives, or if we'll fix it later, right? So you can the developer does have option to bypass it, and with webhooks and other notifications, they can capture if these bypass of push protection are legitimate actions that the developer has taken. So this was about your secret scanning and the different configurations and different capabilities within the and also the AI flavor that you have within secret scanning right now. Moving on, so let's go to the next code offering of GitHub Advanced Security. So the next we have is the code scanning. So what is code scanning? It scans code bases for vulnerabilities. It's a static application security testing tool, right? It can be triggered on events, like it relies on GitHub actions to do the scan. Okay, so and you can define events. On what events do you want the scan to complete, right, or scan to happen? Yeah, a scan can be triggered on push, pull request, or you can do a scan on a schedule, right? You can also define a cron job, and we can do it on a scheduled interval. Drive results to developer within a GitHub platform. So all the security vulnerabilities and data, right, are embedded within the GitHub platform and within the PRs, right? So the developer doesn't have to change his or her context to go to a different dashboard. And with Visual Studio, there's certain kind of Visual Studio Code IDs, plugins that I'll talk about. The vulnerability code scanning vulnerability can be pulled into the ID itself. Okay, so now a developer need not change his context or his or her context to see the vulnerability insights, right? So CodeQL is the underlying engine, right? Extensible with support for other SaaS tools that produce serifs. So as I said in the beginning, right? Not just CodeQL scans can be imported into a GitHub Advanced Security dashboard, right? Under code scanning. If you have a third-party scanner, right, like a container scanning tool, right, or an infrastructure as code scanning tool, right? If any of those tools outputs a format called serif, this is an industry-defined format which reports vulnerabilities in a specific format, right? If a serif format is supported by the tool, you can integrate and import those, push those serif file into the GitHub secret scanning dashboard, and you can in one dashboard you can get insights of your code scanning through CodeQL and other scanning utility results as well. So code scanning, there are various code scanning partners and actions which are already there in the GitHub marketplace, actions marketplace. The marketplace contains integrations to scan containers, infrastructure as code, and other languages using the code scanning, their code scanning expertise, right? So there's certain open source tools which you can also use which have already published their actions into the marketplace, right? You can just import those actions in your YAML file, and then you're ready to run a scan. And then finally, the scan is completed, upload the serif file into the GitHub security dashboard, and you can see the vulnerability in your dashboard. So now, just a quick recap of showcase of how CodeQL works. Okay, so you have the code database. So code scanning basically has two flavors. One is for compiled languages, and one is for non-compiled languages, right? So for non-compiled, it's basically your JavaScript, TypeScripts, your Python codes, and all, right? So we don't have any compiled dependencies on those source code. We just feed the code to the extractor and the parser, and you get the vulnerability output, right? But for compiled languages like Java, your .NET, C, C++, right, there is a compilation dependency that is there. because there are linkages that needs to be made during runtime executions, right? So in those cases, we have to have a build ready state of the application. The build ready state, once the application is a build ready state without any build errors, right? We pass it to the extraction engine, right? So the extractor basically creates trapped files, which is a very proprietary file in CodeQL. The trap importer runs on the trapped files and creates CodeQL database. Basically, your source code gets transformed into a queryable database, like where you can write queries, and that's where the second part of the analysis comes in. This is the first part wherein we are turning the code into a CodeQL database, which can be queried, and then we run CodeQL queries on top using CodeQL compiler, right, on those CodeQL databases, and then query evaluators are there. There are multiple stages which goes through, but I'm not overly complicating things. It's a very detailed step that happens in each stage, right? But then it's a two-stage process. It's two-stage process. One is the extraction process, which creates the database for you, and then there's the analysis phase, right, wherein we have the CodeQL queries. The CodeQL analysis engine runs the queries against the CodeQL database and gives you vulnerability insights. So basically, the final output are the query results for you. Okay. So yeah, so now let's quickly see a demo of CodeQL, how it can be enabled and rolled out in your application, right? So again, similarly, like I'll take this Mona Gallery repository. Okay, so we'll go to settings. Again, code security and analysis. So under advanced security, there's code scanning section, right? So now there are two ways that you can enable code scanning. One is doing a default setup. Default setup is for teams and organizations. Like as I said, like there is an underlying requirement of GitHub Actions to run these CodeQL scans, right? So, but many developers or teams might not have had an opportunity to work with GitHub Actions, but they still want to enable code scanning as a tool, right? Or CodeQL as a scanning tool for their repositories and get the vulnerability insights, right? So we make life easier for them. So there is a default scan option wherein we like obfuscate the complete scanning stages from the user. You just do a default analysis and it just runs a scan for your source code, right? But then for users, it works really well for non-compiled languages, as I said, because there we don't have any build dependencies for non-compiled languages. Right? We just give the raw source code to the analysis engine, and it gives you the vulnerability output. Where it might need a little more manual intervention is where we have compiled languages, right? As I said, not all applications are built in a very standardized way. If you take a Java application, right? A Java application A build step might differ from a Java application B's build stages, right? So that's why we have something called an advanced stage, wherein it gives the users and your DevOps engineers, right, more control on how the application build has to happen and how the analysis has to happen using CodeQL. So I already have action which is defined. Let's go to that action. I'll go to the code. So your action YAML files sit under .github, under workflows, and CodeQL.yaml, right? So this is where your actions workflows reside. So if we just go through this standard definition, so this is a very standard CodeQL analysis YAML file. If you're starting from scratch, right? If you're using an advanced option, right, and you want to use the GitHub Marketplace action for doing a CodeQL analysis, this is the template that you will get. So what it defines is, it says on any push to the main branch or pull request to the main branch, right? Or you have scheduled a cron interval as well. This code, this YAML file, this action should be triggered. So what does this action do is it defines and runs on matrix. Like it says, it checks if the programming language in this repository is of Swift, then we obviously need a Mac OS runner machine, or an Ubuntu machine is good enough for us, right? Then what is the strategy? So in this repository, we have a mix of, it's a multi-technology source code repository. We have Go code, we have Java code, JavaScript, and Python. All the source code, different flavors of technology stack are there in this source code. So it automatically identifies this technology for you once you create this YAML file, right? Next, what it will do is it will check out the repository using certain inbuilt actions of GitHub, right? There's a GitHub action called checkout, basically checking out the repository cloning the repository in that action runner where the analysis will be done. Initialize, there's a CodeQL initialize stage that happens, and then we run the scans for each language. So basically, for all the 4 languages in this stack, like Go, Java, JavaScript, and Python, we'll individually run the CodeQL analysis, right? So and an initialization stage will be run. So now there's something called auto build. Okay, so I said auto build works really fine for non-compiled languages. Okay, so for non-compile, we really don't need the auto build. As I said, there is no compilation dependency, right? But then, like based on certain best practices for Java and your C Sharp, C++ technology, right? CodeQL engine tries to make best assumption of how to scan your compiled language, right, using auto build stages, right? Um, if it fails, if you see the definition here, right, it says auto build attempts to build any compiled languages. If this stage fails, then you should remove it and run the manual builds, which is highlighted in this section, right? So ideally, it will try to make a best assumption and do an auto build for your compiled languages. If it fails, then you should come here and comment out this stage and replace it with the actual build command of your application, right? So this is how the analysis, the build stage, and the one of the stages for your analysis, right? That is a prerequisite for running a CodeQL analysis against a compiled language. This stage is mandatory. So post analysis, we have so next we have the analysis phase, and then as part after the analysis is completed, finally the serif output that will be created. Right? The CodeQL analysis creates a serif file, and that will be uploaded back to the CodeQL security, your GitHub Advanced Security dashboard. Okay, so these are the high level stages that it goes through. So now let's mimic a scan. How we can trigger a scan is, if you see the definition, any push to the main branch, right? So let's try doing a push to the main branch. I'll again probably use this, or let's change the, let's see, let's change my readme.md. I will, mm, okay, so I'm trying to test data for figure. Okay, I'll commit the change directly into the main branch. Okay, so now based on my definition that I had in my YAML file, I should see an action getting triggered off, right? So you can drill down, you can go to the actions page and see if you see the we had 4 technologies in this source code: Go, Java, JavaScript, and Python. So analysis for each of those source code started for me in parallel, right? So this will take a little time. So in the interest of time, what I'll do is I'll show you a repository which already has these the scan completed and the vulnerability reported, right? So let me go to this repository, security, right? So the same source code, I have another repository where the scan is already completed for me. So you can go to security again under the code. Now we should look into the code scanning section, right, of the source of the dashboard. So if you see, these are all the vulnerabilities that are reported post CodeQL analysis, right? It says Flask app is running in debug mode. Query database built from user controlled view sources, right? So if you take this as an example, right? If it says in under the gallery module main.go, there is a kind of it looks like an injection vulnerability to me, right? So you can see how the tainted data is flowing from input all the way to the sink, from the source to the sink, right? The complete path traversal is shown here to the developer. So it makes easier for them to do the analysis and see if it's a true positive, false positive, then they can take more informed decision, right? It also shows you what a vulnerability is, right? In this category, it says an injection vulnerability, right? So what are the general recommendations of fixing an injection vulnerabilities? With code references are given, and also Wikipedia links and CWE references are also given to the developer. Again, there are ways of managing the state of the vulnerabilities. You can either a developer or a security architect, once they come and review the vulnerabilities, right? it's highly recommended that you maintain a state and don't keep your vulnerabilities in an open state, right? You can mark it as false positive. You can say it's used in tests, or you can say it's you won't fix it, right? Because there can be certain reasons of not fixing it, right? It might not be impacting your production system, or the vulnerability that is reported. It might be used in a test environments, right? It's not impacting your production, and you don't want to arbitrarily have an alert open in your repository. So you can take an informed decision after a review, or if you see if it's a legitimate issue, you can also create an issue directly from this control, right? So an issue got created, you can say create issue, you can assign, you can have assignees, you can have labels, projects, on which projects you're tracking this, right? You can have all those milestones attached to this issue. So now under this, you have an issue tagged to this particular vulnerability for your sprints to be. So if you're assigning this issue to a developer and tracking it in a sprint, then it completes the complete life cycle, right? So from your vulnerability identification and to your remediation, right? How it has to be remediated, and who has to remediate, and then which cycle it has to be remediated. So this was about the CodeQL, how you can enable your CodeQL scanning, right? So let me see if this analysis completed. Okay, so this analysis has also completed, right? So code scanning, I have few results here, so which we saw in the other repository as well. Okay, so now I said there are marketplace, other marketplace repos as well. Let's see, GitHub Actions Marketplace. So you can go to Actions Marketplace, and then you can really go to security, right? So this is where all the security related third-party actions, which are published in the marketplace and for your ready-made use, right? So you don't have to reinvent all the integration touch points. If you're using any of these third-party utilities, you can start incorporating their scan stages into the CI, into GitHub Actions pipelines, and post scanning. If these scanning tools outputs data in a serif format, the results can be pushed back to the GitHub dashboard. So now what we saw is a simple CodeQL scan, right? So we see only one tools here, right? So let's see. Okay. So if you see, you can filter by tools, right? So right now, CodeQL is the only analysis engine that we have used to run code scanning. If you're doing a scan from a third-party tool and you have pushed the result into this dashboard, into secret scanning dashboard of GitHub, so you can see other tools, ABC tools also listed. So you can filter down based on the tools and then start looking at the vulnerabilities, triaging the vulnerabilities, and fixing those vulnerabilities. Okay, so this was about CodeQL. Okay, now let's see. Now let's talk about supply chain security with GitHub Advanced Security, right? So how does GitHub help you get your visibility on your supply chain and also maintain a healthy posture of your supply chain in terms of are there security vulnerabilities in your supply chain, in the third-party component usage, and also how do you prioritize and fix those vulnerabilities which are there in your source in your third-party components, right? Okay, so dependency management capabilities within GitHub are the dependency insights. It gives you real-time inventory, license compliance, vulnerability alerting. So these are all part of the dependency insights component within GitHub Advanced Security. Manage your dependencies, depend about security updates, depend about version updates. So basically, once we identify the supply chain components, I said we can have because these open source components are also written by developers, right? So obviously they might have security vulnerabilities, and there can be 0 days as well, right? So before you go ahead and fix any of these vulnerabilities, this is where you get a visibility on your software bill of materials, right? So what is your landscape? What instead of going and identifying reactively of your landscape of third-party usage with GitHub Advanced Security and the dependency management capabilities, you get all those insights in a singular place in your repository, so that you don't have to move around if they're in case of the 0 day, right? Like you have the supply chain, your software bill of materials ready for you in a singular place. So now from there, once the identification part is done, how do you manage those vulnerabilities, and how do you make sure that those vulnerabilities are remediated and they're not, like, we don't keep these vulnerabilities just aging in the system, right? So that's where depend about security updates and version updates come in. So security updates, what it will do is it will automatically create pull requests for you, so that the manual review, the manual analysis part is taken care of by GitHub, right? The intelligence, GitHub has that intelligence to create automated pull requests for any version updates that needs to be done if your application is using an open source component which is outdated, right? Or if there are vulnerable components in your in your supply chain, right? And you need to upgrade because a fix has been identified in a later version of that open source component. So GitHub can automatically create pull requests once you enable those features for you. So it reduces an overhead on the security and development and architects on manual analysis part of it, right? Because the data is already ready for them as a PR. They just need to do a risk assessment and approve the PR or reject the PR based on the impact of that change, right? Fix and publish vulnerability info. So some best practices, like it's recommended to publish your security in case of a 0-day or vulnerability, critical vulnerability that is been identified, right? What is your security policy, right? Within the organization, where do you define that, right? So a security md.md file is the one that we recommend by teams to maintain. Who are the security stakeholders in case there is a breach that has been identified, who and what process should be followed, right? Everything should be documented in security.md. Security advisory databases, there are ways you can do vulnerability disclosure for your, if you're maintaining an open source project, how do you disclose a vulnerability to your open source user community, right? You're responsible, basically responsible vulnerability disclosure. And the GitHub advisory database, obviously, right? If you're, again, if I said, if you are an open source maintainer, you identified a 0-day, you publish the vulnerability into the security advisory database. So any user who uses your open source project will be notified that a 0-day vulnerability has been identified. So basically, the complete ecosystem is covered with the dependency management capabilities within GitHub. So dependency graph, it's available both in enterprise cloud and enterprise server. So basically, it parses through the manifest file and the log files or their equivalents for supported ecosystems, right? And gives your dependency insights. Basically, what are the composition, what are the components that are used in building an application and maintaining your application, right? So during your in its running state. Not just the direct dependencies, it also gives the insights on the transient dependencies, right? Like there are dependencies which directly we don't reference in our manifest files, but when the application is in a running state, we have a transient like a transitive dependency on those third-party components. So we give you visibility on those kind of transitive dependencies as well, and the vulnerabilities that is being carried by those transitive dependencies. Identify items added when a push to the default branch is made, right? Scans for JavaScript, Java. So these are some of the technologies that we support. If you go to our GitHub Advanced Security documentation, so all the supported package managers and the technology stack that is clearly listed out for your reference. Okay. Dependency review. So this is where DePenda comes in. So this is the automated bot which does all the magic for you. So what it will do is it will automate and create pull requests for security and version updates. So basically, keep your project secure and up to date, but monitoring them for vulnerabilities and out of date dependencies. As I said in the previous slides, DePenda will keep monitoring once you enable this feature. If there are any vulnerable third-party components or there are components which are outdated, right? So it will keep track of those kind of components and create automated pull requests for you. Integrated with the developer workflow, DePenda is integrated directly into the developer workflow for a frictionless experience and faster fixes. Okay. Rich vulnerability data. So because like we curate vulnerability insights from multiple sources, right? So we have a very rich data advisory database which gives insights on the vulnerabilities that are reported, so that teams can take more informed decision on the impact of doing any change, or like if like if the vulnerability that is reported actually impacts the development community or the project that is being scanned for, right? So you take more informed decision with all the data points embedded within the GitHub tooling itself, so where developers come in day to day on a day-to-day basis, right? So some matrices that we have seen. So mean time to remediate for repos with GitHub Dependa security updates. Typically, what we have seen is 180 days plus is the MTTR for fixing this kind of security updates in third-party components. But with Dependa updates, automated pull requests, and all those features enabled, we have seen a drastic change in these numbers. Right, we have seen the MTTR drop from 180 days to 40 days, which is a drastic drop. And because the end goal is not just identification of vulnerabilities. Right? Like identification is one core component, but final goal is to how do you fix, how fast can we fix these vulnerabilities so that we reduce our risk exposure, right? So this is some actual industry numbers that we have seen with enterprises using this kind of depend about security update features, and their MTTR reducing over a period of time. Okay, time for demo again. So now, so we'll go back to our Mona Gallery MS Reactor, this repository. Again, everything sits under our settings, code security and analysis. So this is where we start enabling our features for dependency graphs, right? So what I'll first do is I'll just say enable my dependency graph. So the moment I do an enable, it will basically list all the third-party components for me. I'm still not gone into identifying vulnerabilities or outdated packages. I'm just enabling a vanilla SBOM scan for my application or my repository. So once you enable it, where do you see the data for your supply chain, right? You go to insights, you go to dependency graphs, right? And so if you see here, so these are all the dependencies that are being identified in my application. So we have quite a lot of dependencies, right? It also tells you where the dependency is being referenced from. And it also gives you an information on the license type of the dependency, okay? So you can export this SBOM, right? And so you can do that. Like we support a standard industry standard. I think SPDX format is supported. You can export this SBOM, and if you have a centralized tool where you're maintaining your supply chain data, you can import this SBOM into that your another dashboard as well. Okay, so if there is a need be. So now we have enabled our dependency graph. So next, what I'm going to do is I'll go ahead and update my DePenda, right? So this is where the uh, vulnerability alerting and other features come in, right? So now I'll go ahead and enable DePenda alerts. It says receive alerts for vulnerabilities that affect your dependencies, right? So I'll go ahead and enable this. Okay. So now I should see more vulnerabilities getting reported. So if I go to my security dashboard, so if you see my DePenda, I have 24 alerts reported on my third-party component usage. The critical vulnerabilities that are reported. So I have a buffer overflow in PyCrypto, right? So it says which versions are affected. So affected version is anything less than 2.6.1, right? It gives you a criticality CVS scoring criticality, right? Tags, the dependencies, the weakness, the CW numbers, the CV IDs, right? See advisory in GitHub advisory database. You can see all those data and linked to the advisory database as well, right? If someone wants to get more information on the vulnerability that is reported in the open source component, right? Again, once your analysis is done, if you feel that these vulnerability is not impacting your application, right? You can very well maintain a state. You can say that a fix has been started, or no bandwidth to fix this. Risk is tolerable to this project because in certain cases, even though there's a vulnerability in the component, you might not be exposed directly to your application might not be directly impacted with that vulnerability, right? Because you might not be using a call directly to the vulnerable method with the third-party component, right? So we give you options to maintain the state, and as I said, this is very important to maintain the state so that anyone who is coming as a security or an enterprise architect or your management, right? So they know what is the state and what kind of actions you are taking on these vulnerabilities that are reported, right? So do maintain the state, okay? But then again, as I said, these are the features. Like we saw, first stage was enabling a scan on your source code to get your visibility on your open source usage, the SBOM. Then we enabled your dependable alerts, right? Next, what we'll do is we'll go and update this dependable security updates and the version updates. So these, when we enable, these are the features basically which will create automated pull requests, as I said in the beginning, right? You can define some configuration file like what package ecosystem I want to scan for the Maven package ecosystem, right? On a weekly basis, you can define, right? You can commit the changes, right? So these two features basically will create automated pull requests for you based on the definition that you have given in the YAML file, right? At what frequency the scan has to run, You can also group vulnerabilities. So there are certain ways of grouping dependencies into if there's certain category of vulnerabilities that you want to group together, right? Instead of creating individual pull requests for each vulnerability, you can group a certain type of vulnerabilities together based on your definition. And then instead of creating 10 pull requests, it will probably create one pull request so that you have a more manageable chunk in your for developers to work on. Okay, so if you see here now, there are two pull requests which are created, automated pull requests. It says bumps some post CSS from 8.429, 8.4.29 to 8.4.32. Release node, change logs, commit, right? Everything is referenced here. So um, so all the information, the labels, like it's a JavaScript, right? So which project impacting all the milestones that needs to be taken care of, right? So all the information is available for developer or your architect or the security architects to take more informed decision whether or not to merge this PR or just reject this PR because it might not be impacting at all for your organization, right? So yeah, so this was about your dependable and dependable vulnerability. How do you secure your supply chain in using GitHub dependency management and the dependable tooling? And the just last point that I wanted to showcase here is under dependable alerts again, you can write custom rules, right? So let's say what kind of rules you can write. You can define a new rule. Let's say enabled. You can define rules on severity. So, for example, let's say you have enabled dependable vulnerability reported, right? And it has created some 100 vulnerability for you, right? So it might create an alert fatigue for developers, right? So all 100 vulnerabilities might not be impactful for your security team or for your development or your application, right? So in that case, you can write certain rules to suppress vulnerabilities, right? Because you don't want this hundreds and thousands of vulnerabilities just lying open in your dashboard, right? And someone coming and getting alarmed, right? What is happening with this application, right? So you can create alerts on severity. So let's say I'm okay to have a low severity vulnerability in my open source component, right? So once you define this, you can say the alerts will be dismissed. Till what point it will be dismissed is until a patch is available. If there is no patch from the open source community, right, of the open source maintainer for that particular vulnerability, there's nothing that you can do, right? So, and there's no use just maintaining that alert and just increasing the count of your vulnerabilities, right? So you can suppress that alert till a vulnerability patch is available, or you can dismiss it indefinitely because you feel that low vulnerabilities are not something that impacts your application or your enterprise, right? So with these kind of rules definitions, you can prioritize uh, faster remediation cycle for your dependable LS or your dependency management third-party component usage, right? So as I said, the whole idea is not just report vulnerabilities but also fix vulnerabilities, right? So now you can start taking more informed decision and more prioritized decision, like what to be fixed first, what do we fix later point of time, right? So with these kind of rules and definitions around dependable usage. So yeah, so this was around your dependencies, right? And the last bit that I wanted to showcase is your um, 1 second, is your security dashboard. So now, again, recently launched in GitHub Universe, we have something called the security overview. This is where you will see all the open alerts, right? The trending information of your the of how your application has been faring, or how your organization has been faring in terms of your security posture, right? How many alerts are there? Increasing trend of alerts? Are people fixing those alerts? Because ideally, you should see a downward trend of alerts over a period of time, right? As an enterprise or leadership team, right? So they might find it very useful to see the risk posture of your organization, right? In terms of your application security posture, right? You can drill down on certain dates, right? You can see age of alerts. Are there secrets? We saw that secrets push protection, right? There are ways of bypassing push protection, right? Are there secrets which are bypassed by developers, right? What is the mean time to remediate? What is the net resolve rate, right? Activity alert, right? How many new vulnerabilities are generated vis-a-vis how many are closed, right? So, and then top impacted repositories within your what do you say, within your organization. So you take more informed decision with all these data presented within a singular dashboard, right? Similarly, you have risks, right? which repositories are the most impacted in terms of the vulnerabilities, number of vulnerabilities that are reported. In terms of coverage, all your applications being covered with a dependency or with your advanced security tool sets? Are there repositories which are, so if you see here, right, 55% of the repositories are protected with DePenda. Uh, Code scanning 61% are protected, 44% in terms of secret scanning, right? So you take more informed decision. How do you roll out advanced security, and also get visibility on the risk of your applications in your organization, right? Um, so so this is what I wanted to cover today. So we saw the different components of application security in GitHub, right? In GitHub Advanced Security, um, the secret scanning, the code scanning, the depender bots, and also the security dashboard, right? So we saw each of them in action, and I hope this was informative enough for you to take back and try it out, right? Some of the features are readily available for public, right? If you are already an enterprise customer of GitHub and have enterprise licenses, some of the features will be available to you. And as I said, some of the AI features that we talked about, which has been released recently in Universe, you can get into you can request for access. Or like it's still in very limited private betas, but you can get into the queue for access to those feature sets. So that's all from my side for today. Any questions? I don't know if there are questions which are there. Rashmita, any questions from anyone?
There's no question at the moment,
Mm.
Abhishek, but I think if there
Okay.
are any questions, probably, they'll reach out to
Okay.
you.
Yeah.
Yeah, yeah, yeah.
Sure. So thanks everyone for your patience and your time today. As I like hope we had a 1 hour session. I tried to showcase, at least touch upon the different use cases of advanced security, just so that you get visibility on what's there and what has been released new, right? And just one last point that I wanted to showcase is, if you want to keep track of all the GitHub Advanced Security releases cadence, you can go to github.com, github.blog, the changelog, and the label is Advanced Security. So here you can get a list of all the releases, latest that is coming out of Advanced Security from GitHub, right? So keep track of all the feature sets. Sure. That's all
Thank
from my
you.
side. Thanks, Rashmita. Thanks,
Thank you
everyone.
so much, Abhishek, and thank you all for joining us today. Please visit Microsoft Reactor website for more upcoming session. Feel free to use the Learn module link shared in the chat section. This will give you access to additional resources to take your learning further. Thank you all once again and enjoy the rest of your day.